recorded to this computer. Here we go. So today we are looking at this idea, this concept of solving problems with systems of linear equations in two variables. So yesterday we jumped in, we dove in, we got started, we looked at systems of inequalities, right? So systems of inequalities is similar to looking at systems of equations, because when we look at systems of equations and they have one solution, that means they crisscross, and that one point where that intersection point is called the solution to that inequality or that equation, right? When we move into this realm of inequalities, we introduce this concept of shading on one side of the line, right? So we talk about the concept of shading on one side of the line, and then we look for that double shaded region where both of the inequalities have a shared sort of solution set. And remember, we talk about solution sets when we're talking about inequalities because we talk about solution sets when we're talking about inequalities because there's not just going to be one solution to the system of inequalities. It's going to be like multiple points in that shared region, because we're talking about the shading aspect of it. So the shading aspect of it is going to pull in a bunch more solutions that are available for you to have. So let's look at our learning goal for the day. So today, listen, today is the last day of learning for this unit. We're moving into a new unit. Not next week, but the week after, because we're doing an IAB next week. So our learning goal for the day, the last learning goal for our for this unit is going to be, we're going to be using systems of inequalities to solve some problems. That's all we're going to be doing today. We're going to be looking at some systems of inequalities, and we're going to be pulling out some information from those graphs. So let's take a look at slide number 3. I want you to take right now, I'm going to give you 2 minutes to decide which one of these does not belong and why. So I want every single person in the chat, that's going to be the proof that you are back. It's going to be the proof that you are back in getting ready with us. I need every person to take 2 minutes to decide which one of these graphs does not belong and tell me why. Okay, go ahead, take 2 minutes starting now. Let me know in the chat which answer you choose. Max, thank you. Ooh, nice one, Gabe. Ian, very good. Gwen, very good. Kyle. I like it. This one's fun, in my opinion. I like this one because there's literally answers for all of these. Nice job, Gwen, for that explanation. Nice job, Abby Wasta. Nice job, Sadie. Nice job, Peyton. Ooh, nice. Oh, I like that one, Cameron. I'm excited to see your reason. What do you think and why? Ooh, I like that one. I like that, Peyton. Peyton, Cameron. Okay, I need Cindy, Adam, Connor, Junior, John, Cindy, Adam, Naseem, and Abby. Let me know which one you think does not belong. Let's go. I need answers from everybody. Let's go. Answers in the chat. Prove to me that you are here. Let's see what you're thinking. Connor, Abby, John, Connor. Abby Jr. Cindy, Nassim. Adam and John. Perfect. Very good. Nice job. Let's see what people are thinking. A lot of people are saying letter A, and a lot of people are saying letter A for the reason that it is the only one that doesn't have a shaded region in it. So what do we know about, like, if we were to write out something that represents it? Would it be an equation? Oh, perfect. Thank you, Abby. No, I saw that. I marked you. That was me marking you down. Would it be an equation? Would it be an inequality? What would it be for letter A? If there's no shaded region, it would be A or an. What do we think? Nice job, Ian. Ian said that it would be an equation, and I would have to agree, because when we have an inequality, we have to shade some regions, right? And because there's no shading on A, we can sort of make that inference that we're dealing with an inequality there. Very good. Nice job on that one, Ian. That was sort of a extra question. Nice job on that one. A lot of people were also saying, let me see what else people were saying. A lot of people were saying C, because a couple people said C because there was like an overlapping region that was like shaded. Like if you look in this little section right here, this is the overlapping shaded region. So maybe that is like a solution set for these two inequalities, because we know that when we have inequalities, that's when we start shading. So these are shaded inequalities. This is going to be our solution set, that region where your solutions are going to lie. A couple people said B because it was the only one that had no solutions. Because if we look at the two shaded regions here on B, there is no spots on this graph that there's going to be an overlapping region. So there's this solution, or the solution to this system of inequalities would be no solutions. Nice job. And then one other person said they chose D. No, like 3 people said that they chose D. And let's see why people chose D. People chose D because it was the only one that had one either equation or inequality, which is a good reason. So they looked at it and they were like, this one only has one line on it. So that means only one inequality, when all these other ones have 2, represented by these different lines and then these different shaded regions. Nice job. Once again, another question that just sort of got your brain thinking. So now if we move forward to slide number 4, the last section of this unit is asking you to look at this graph. So here is a graph of the inequalities in this system. Here are the graphs of the inequalities in the system. So we have this system right here, and we have the graph of those two inequalities. Your job right now is to, let me just scroll this down a little bit so I can see. Your job right now, I'm going to give you 2 minutes to decide whether each of these points is a solution to this system. Be prepared to explain how you know. So you need to look at all 5 of these ordered pairs here. And using what we know about solutions to systems of inequalities, you need to decide, is it a solution, yes or no? If you think yes, you're going to circle it. And then I want you to list off other solutions that aren't listed here. Okay, and I'm not saying that first one is a solution or is not a solution. I just sort of put it there. So I want you to take 2 minutes right now to look at all 5 of these and decide, are they solutions using what we know about systems of inequalities? And then I want you to list off a few more points that could be considered solutions to the system. Okay, take 2 minutes right now. Once you start to get answers, once you're finding ones that you agree with, let me know in the chat which ones you are thinking. Oh no, we lost Ava. Her internet probably went out. Nice job, Gabe. Ooh, nice job, Peyton. It's a good choice. Nice job, Gwen. Nice job, Kyle Kelly. Okay, take 20 more seconds for yourself. Nice job, Kyle Kelly. Nice job, Peyton. I want some people to tell me in the chat. Everybody for number 1, tell me, do you think number 1 is a solution, yes or no? Number 1, is it a solution, yes or no? Okay, nice job. Thank you, Peyton, Max, Ian, Abby, Gwen, Gabe. Very good. I know that you guys put them in the chat earlier, but very good on that one. Let's take a look at number 1. Number 1, if we want to, can I actually, first of all, when you were looking for solutions, whether or not they were solutions to this set of inequalities here, the system of inequalities, what were you looking for, like on the graph, for it to be considered a? Okay, so some friends plug them in, okay, but also we could look at that graph and what can we do with it? Abby Wasta, what were you thinking when you decided whether or not it was a solution or not?
I looked on the graph and I looked to see if the solution, like if the point was in the area where the shading overlaps.
Very good. So yes, Kyle Kelly, that works. If you plug them in, you could plug those points in and see, are they true statements for both of them? Yes, but that does take you a little bit of time. Or you can just be like what Peyton said or Abby Wasta said. You can look and you can see, does it fall within this shaded region here? This double shaded region. You're going to be looking inside this double shaded region. Does that point fall in it, or on a dotted line in that region? So we said number 1 did not, because if we go over 3 down to -5, you're here, and it's only a single shaded portion of the graph. So that one's not going to work. Nice job on everybody that said no there. So now let's take a look at number 2, 0, 5, over 0 up to 5. What do we think about that one? Thank you, Peyton, on that one. Very good, Gwen. Very good, Gabe. We're going to say yes on this one as well, because if you look at, so like you see a little 4-way little pointer there. If you look at where I'm pointing to the left, that would be where 0, 5 is. And that would be right there. That would be in that double shaded region. You could also plug it in and see, but that would take a little bit of time. So I would circle this guy here. Now we need to look at -6, 6, over to -6, up to +6, and it falls on that solid line. So if there's a solid line there, what were you thinking about whether or not it was a solution or not? Gwen, what were you thinking about this one? No? It uses a symbol with the line under it, right? So that's or equal to. So Gabe, what were you thinking about this one? Go ahead and unmute, buddy. Yeah, no, number 3. It's -6, 6. So over -6 up to +6.
I thought it was a solution because it's located on the graph.
It's located on the graph, right?
In
And
the solution region.
it's
On the
located
solid line.
Very good, Gabe. You're anticipating all my questions. I love it. So he said, yes, it falls within that double shaded region on a solid line. So if you're looking at a point that falls on a solid line, you're going to say, yes, that is a solution. If you're looking at a point that maybe falls on a dotted line, like directly on a dotted line, you're going to say, no, that's not a solution, because when you have that dashed line, that means it's not or equal to that value. So if it falls on that line, it cannot be equal to, for example, negative or 8,8. 8,8 would not be a solution here because it falls on a dashed line on that border region. Does everyone see the difference between if it falls on a solid line on a border region versus when it falls on a dashed line of a border region? Does everyone sort of see the difference between a dashed line and a dotted line here? Nice. Thank you, Abby. Thank you, Gwen. So number 3 would be a solution. Good. Now, if we look at 3 over 3, up 3, it falls on a dashed line here. So what do we think about number 4? Thank you, Abby Wasta. What else? What are people thinking? Nice job, Gwen. Nice job, Peyton. It is going to be a no-go on this one because 3 falls on this line, but it's not a solid line. We can only say that it is a solution if it falls on a solid line. This guy here is a dashed line, so we can't say that it's going to be a solution because it falls on that line here of 3 right here, but it's on a dashed line, so it's not going to be or equal to, so it can't be 3. Okay, do you see that difference there, Gwen, between if it falls on a solid line like this versus if it falls on a dashed line like this one? Because there is a little bit of a difference there. Okay, perfect. I just want to make sure that you know. So then let's take a look at -2, -2, over to -2, up to -2. What did we say about that one there? Where my right little pointy is pointer. Nice job, Peyton. It is a true statement. It is going to be a solution. -2, 2. Oh, wait, no, -2, -2 is down here. Mr. Wayne got it wrong. This one would be a solution. Yes, because it falls on a what kind of line? A solid line. Yes, Junior. Because when you look at this solid line here, this equation line here, it's going to hit at -2, -2, which is a solution. If it falls on a solid line, it is a solution. And even though like you hit, it's on a dashed line, it's still on a dotted line. So it's going to be a solution. Woo woo. Nice job there. Oh, it doesn't work? Let's see. Let's plug it in and solve. Let's plug it in and see. Let me grab a text box here. Good. Thank you for calling that out, Gabe. Let's look at it. So we said -2. So, oh, because it's not or equal to. That is the correct piece of that, Gabe. Thank you for catching that. So if we plug -2 into this first equation here, -2 is less than the -2, right? Because it's y and x. So -2 is less than -2. Is that true? Good catch there, Gabe. Is that true? -2 is less than -2. No, it's not true. So when Mr. Rain got confused. I'm sorry. So when we look at a set of inequalities here, right? If you're on a boundary, and if it hits a line and it's where it's like our intersection point of those two equation line or inequality lines. If they're both solid, then it would be a solution. But because this guy right here is a dashed line, it is not going to be a solution. Very good. Thank you for that catch there, Gabe. Good catch there. So This guy is not going to be a solution. Who can list off one more solution that they found for this inequality, for this system of inequalities? Give me another coordinate pair that could be a solution. 0,8. Very good, Abby Wasta. There are a ton of them. What's another one? Nice job, Gwen. 2, 2. Let's see. Is 2, 2 going to work? Over 2, up to 2. Is 2, 2 going to work? Why not, Gwen? Unmute. Let us know. What do you think?
Because it's not on a solid line, it's on a dashed line.
Very good. Because this 2, 2 is on a dashed line, that's not going to work, but good catch there. Nice job, Abby Wasta, because that line is dashed. Who can give me another coordinate pair? Very good, Junior. Let's test it out. -4, 6. Very good. Nice job there, Junior, because it falls squarely in that shaded region. Very good. That double shaded region. Sorry, being more specific. Who can give me 2 more? I need 2 more people to give me coordinate pairs. 2, 6. Over to 2, up to 6. Nice job, Abby Wasta. I need 1 more person to give me another ordered pair. Somebody other than Abby or Junior. Naseem, what was one that you got, buddy? Nice job, Max. Max got -8, 10. Very good. It would fall right up here on the solid line. Good one there. Connor said 3, 4, over to 3, up to 4. Very good, Connor. 3, 4. One more, -4, 7. If we go over to -4, up to 7, it falls squarely in that double shaded region. Nice job there, Ian. -4, 7. Very good. Awesome, awesome, awesome. So we want to make sure 2 takeaways from this little activity here. If we are given a graph with a system of inequalities, solutions fall on, if you're looking at a boundary line of a double shaded region, if it is a solid line and it falls on a solid line, you're going to say, yes, Aru, that is a solution to both of those inequalities. If it falls on a dashed line, you're going to say, no, it's not going to work as a solution because it's not or equal to. And last piece, what was a little bit of a trickster, if you have a region like your intersection point, your intersection point for your 2 inequality lines, if one of them is dashed and one of them is solid, that is not going to be a solution because they both have to be solid if you're looking at an intersection point and seeing if it's a solution. Okay? Nice, nice, nice job there. Awesome catch on that, Gabe. I appreciate your help today. Let's take a look at the next piece of this here. So for points on lines, how did you determine if they were or were not solutions to the system? I want you to take 1 minute right now to sort of sum it all up. In your own words, how did you determine if a point on a line was a solution to a system or not a solution to a system? Take 1 minute right now. Okay, I'm gonna have, let's see. Oh, this auto fill, sorry guys. Okay, I'm gonna have, let's see, Sadie. She's gonna help me out. Ooh, nice, Peyton. Actually, what I think I'm going to do is I like what Peyton wrote. So I'm going to come over here. I'm going to do a little bit of, I'm going to like do a little bit of correction, but it looks good. So if you, let me just make a few corrections and I'm going to read through it. If you put points in, so like in that double shaded region, and they fall, I think that was supposed to say fall, fall within that shaded region, they are a solution. Good. Anything below the dash line is not a solution because it has to be solid. So anything outside of the double shaded region is not a solution. Let's think about the lines now. What do we know about the lines where we can determine if it is a solution or not? Sadie, what were you thinking about? So the first part, Peyton said, if it falls within the double shaded region, it's gonna be a solution. So Sadie, can we add anything to that? Because that's perfect. Abby Wasta, nice job. Do you want to unmute Sadie and give us a shot? Give it a shot? Or no? Oh, okay. That's not a problem. I'll grab what Abby Wasta said, okay? And then I can have you, and then I'll give you more notice next time, and you can type it out, okay? Not a problem, Sadie. Okay, so let's take a look at what Abby Wassa said. So there were two pieces to this sort of idea for today. First, Peyton told us if it falls within that double shaded region, it's going to be a solution. Then Abby Wasta added that if a point falls on a solid line, it would be a solution because the solid line means or equal to. If it falls on a dashed line, it won't be a solution because the dashed line means it's not or equal to. Very good. Nice job on that one. Really also last sort of summation piece of this is if it falls on like an intersection of a dashed and a solid, it is not going to be a solution because it needs to fall on a double solid. Nice job on that one. Very good. Nice job. Okay, so then now I'm going to actually I'm going to take both pieces of this. I'm going to put this in the chat in case you didn't get a chance to write this all down and you want to put it in your slideshow. Okay, so I'm going to go like that. It's kind of a big message, but there we go. I'm going to move forward to slide number 6. Slide number 6, it's matching solutions to systems. Okay, so we have 4 graphs here. We need to choose the graph that shows the solution to this system of inequalities. So you need to look at this system of inequalities and think about where would you be shading, and you're going to identify the graph that has the correct double shaded region selected. So I want you to take 2 minutes right now to think about this system of inequalities and where would be your double shaded region, and then grab it and put it in this box here. Okay. Boom. Or actually, I would move the red box around the one that you want. Okay. I'm not saying that that's the one. That was the one that was easy to grab. Taking another minute to work on this one. Actually, I'm going to say 2 minutes. Go ahead. Nice job. Nice job, Gabe. I'm gonna go like that, and then I'm gonna does it fit? Okay, good. Okay. Awesome. We're taking another 42 seconds. Nice job, Kyle Kelly. Okay. 3 plus 2. Okay. So what I'm doing is, I'm picking that point 1 comma 1, which would fall right here, and I'm plugging it into this first inequality here. You plug it in, you get 1 is greater than 3 plus 2, which is not a true statement. So we're looking at this dotted, this dashed line here. 1, 1 is not going to be a solution. So we're going to be shading for this dotted one on the right side of it, right? So I'm going to move this box right here. So I know I'm talking about like the left side of this line here, this dashed line. So then if I look at and I test that second inequality with 1, 1, we're going to see what happens. If we look at -4, so -4 plus 3 is less than or equal to 12. Is that a true statement? -4 plus 3 is less than or equal to 12. Is that a true statement? -1 is less than or equal to 12 is a true statement. So this solid line here is going to be shaded below because 1, 1 is a solution. So we're shading below this solid line here and to the left of this dotted line here or dashed line here, that region that would be the shared solution set would be this little triangle right here. So it would be this fourth option down here, because on this dotted line, we're shading to the left. On this solid line, we're shading below. The only shared region here is this little triangle right here. Okay. That guy was a little bit challenging. I'm gonna give you the option on the quiz to look at and use a graphing feature to sort of check your work. And that is what we are working on for today. So this afternoon, let me tell you, you do not have to do this inequality matching piece. This is going to be our warm-up for tomorrow. I'm going to throw this on our slideshow for our warm-up tomorrow, where we're going to be matching these inequalities. So please don't feel like you have to do this today because it's going to get migrated over to tomorrow. Your afternoon work for today, you have 2 things that you are working on today. Number 1, you have a end of unit review, Elastic sort of quiz review, because tomorrow in class, we are going through that quiz review, because on Friday, we have an end of chunk. I like to call it an end of chunk assessment, but it's going to be a shorter assessment, so it's going to be designated as a quiz. Now, okay, mucus here, sorry. So that is what you're working on today for your afternoon work, is that review activity. Also, I want you to try to give me 15 minutes your path in Alex so that we can get to that 60 end of the week. Okay. Yes, you can turn slideshow in, just make sure that you are able to access that afternoon work. The afternoon work is actually attached in the classroom as well. It's designated 12 to 10 afternoon work. It takes you to the Edulastic assignment. Someone should not have turned it in. We should not have, I don't understand. Anyways, I will see you all tomorrow. So please, Kyle, if you can take another shot on that, please try to take another shot on that. And because that is not a good score, I need you to give it another shot. Awesome. Let me know if you guys have questions. I'm going to be running a group today from 1:30 to 2. If you have questions you want to jump in, you can. If not, I will see you all tomorrow. Have a great day and reach out with questions. Bye, guys. Hey, Ava, how you doing? Any questions? Oh, no? Okay.